Hello, we're the Sharpshooter team, and my name is Sanchez. And Fullerton. For this project, the requirements and specifications. The main purpose for this project was to interface a PMOD joystick to the Nexus board to control. The main idea at first was to drive an RC car, but that didn't work. So we decided to move to something a little bit more challenging, crazier. So
our first RC car was just a single, either it's fully driving or it's fully off, and you can't really adjust the range when it's all or nothing, so we had to go with something else.
For this one, as you can see, the joystick has 2 push buttons, and the helicopter has 2 missiles. So another idea was to use those push buttons to shoot missiles. Another requirement was to use the PMOD DAC, but not the same as we used it before in class. We use it as, for this project, we use it as a dual output. And you can talk a little bit more about the dual output.
Alright, first I'm going to walk you guys through our block diagram. Well, you have your PMOD joystick, and it's taking, you're initializing it, and then sending back your directions, and that goes to your DAC. The thing about your DACs is there's a dual output, and one of your DACs will actually send an output for your signal select, or your, slave select, and your clock to the other one, and they both end up sending out a GPIO, like a data line to the actual DAC itself, so that you can control the output for the voltages, the 2 outputs. And it will be end up sending to our trial wireless receiver transmitter, which wirelessly sends it to the receiver and controls the helicopter.
For the software flow diagram, first, well, you start up. Then the first thing it does is initialize the PMOD. Once the PMOD has been initialized, it lights 2 LEDs. That means that the PMOD is ready to be used. So that's where it starts to interface with the user. And from there, it's wired in a way that we're using the remote control as a transmitter, hooked up to the DAC, and from there you can send and receive.
First, one of our big problems was the PMOD. The PMOD's range goes from 0 to 1032 in decimal. That's 10 bytes of data to store it all in binary. However, it sends you 16 bytes of data 16 bits of data, which is 2 bytes for each access. And then the last byte of data, which is a total of 5 bytes, is for the 2 push buttons on the controller. This was a real issue because pulling that data and seeing actually what you're receiving from the joystick was kind of a big problem we had. And we actually would display each byte of data from the joystick on the LEDs to see what was actually going on with it, coming back from it. Another thing we had to set up was the DAC. We had to set it up into dual output mode so that you had 2 voltage outputs. This was kind of a problem because the second output we integrated had a different voltage range than the initial one. Its lowest voltage range was actually 1.3, and it went to a max of 3.6, which we needed to start at 0 for our controller. Because the way the controller actually works, which was another thing that we had to figure out, is how it actually worked in itself. And it uses a voltage range to control up and down, left and right. The left and right stays at a middle voltage, and then it fluctuates to 0 in the max, whereas up and down starts at 0 and then goes to max.
So, as he mentioned, we have to do some reverse engineering and figure out the signal that the control was sending for this project. Project status. Well, so far we got all components fully integrated. It's ready to, the PMOD is ready for user interface. It works.
The only thing we really didn't get working was the shooting of the missiles. We actually wanted to have that in there because it'd be fun to actually push one of the buttons to get it working. But the PMod gave us so much trouble that we didn't actually get it working until this morning. It was a real big mess. Alright.
So with that, we conclude our presentation.
We had any questions?
You have the shoot down.
Oh, you can use the actual original button that comes on the controller, but we didn't integrate it into the Nexus board yet. It still works functional with the controller.
Question. So you use the separate IP core or the
Yes. IP core to the GPIO to put out the data. But we figured it would be the exact same as the original DAC output, but it's had that different voltage range, which okay, gotta be. Alright, let's see if this thing. It's really tricky because the sensors from the bottom, the actual receiver on the sensor on the helicopter is right down here. So the actual sending of the signal and the receiving of the signal kind of bogs up sometimes. The actual voltage flow bogs up sometimes. So if you guys get it right, we'll get a good little show going, and we'll probably end up running into something. It likes to run into everything, so. So watch out, you guys in the front.
Darn your eyes.
The voltage, the actual signal can get cut off midstream, so it can still be flying at max voltage, but hasn't been told to shut off yet, so it just keeps going. But I mean, portable. Just have to have a computer and a little box. Mesh.
So let me give it a shot. It's kind of unstable and it's hard to fly.
Gonna get it?
Or
Get it full power.
Fail mode. Scratch and burn. No, come back. That's sick.
make a fly and see if we can show
Alright,
it.
alright.
Cool. No, don't have a half party, you little thing.
It likes being tricky. Alright, let's just shoot myself for fun then. There we go. There you see, there's a shooting bar.